Today we are going to solve some problems on calculation of pH for strong acid, strong base and weak acid. This is a combined worksheet for pH calculation for strong acid, strong base and weak acid. So without wasting time, let us start with the first problem. Calculate the pH of 0.01 molar solution of nitric acid. So student, 0.01 molar, that means 0.001 mole per dm cube. So here we have to calculate for nitric acid. As we know that nitric acid is a strong acid. So when nitric acid is strong acid, so here we will use a very simple formula. As we know that when there are a strong acid, we use direct formula. When you have strong acid, we use direct formula, that is pH is equal to negative log to the base 10. If you will write 10 base, no problem if you will write. Okay. Then here important thing students, when strong acid is there, whatever acid is there, you have concentrated HNO3. So this is strong acid, that means its concentration is equal to concentration of H plus, because strong acid dissociate completely, dissociate, ionizes or separate completely. So here whatever concentration of HNO3 is given, it is equal to concentration of H plus. So put this value negative log 10, 0. Just let me check one more time. 0.001. Put it directly into calculator student, you will get answer. So my answer is pH 3. So in this way, if strong acid is there, you need to use direct formula, because concentration of given acid is equal to concentration of H plus. Now coming to second problem. You can pause video and note down. Calculate the pH of 0.02 molar formic acid with Ka is 1.8 into 10 to the power minus 4. So student, here you given is dissociation constant and formic acid. This is organic acid. Organic acids are weak acid. So this problem is related to weak acid. Now just we need to recall formula which we used for calculation of pH for weak acid. Weak acid. So student, weak acid means it dissociate incompletely. Incomplete dissociation. So when we say weak acid, this is the reason student, we have to find out extent of ionization, and we get that extent of ionization from equation, from dissociation constant. So here given acid is formic acid. So formic acid means methanoic acid. So this is methanoic acid. So if you want to write down dissociation of formic acid, it will be, or we can call, see student, always just this structure is like this, okay, C double bond O OH. So carboxylic acid lose this hydrogen, please don't try to remove this hydrogen. So it will be HC double O minus aqueous H plus aqueous. So in this form we can write HC double O minus plus H plus. Just for to make it more clear, I told you like this, but it is not needed. This is the correct way. So if you want to write down Ka, dissociation constant, it is equal to, applying law of mass action, you get equilibrium constant, which is product of concentration product over concentration of reactant. Now students, as we know that there is a very less extent of ionization, so concentration of H plus is equal to concentration of Ac minus. So our formula, we are deriving formula one more time. You can directly also use formula. So H plus square concentration of acid. So here student, if you want to calculate pH formula is negative log to the base 10 H plus concentration. So our first requirement to calculate H plus. So H plus, just rearranging this formula, H plus is equal to Ka into concentration of acid. Student, if you can recall this formula, if you can memorize this formula, just memorize this formula. When weak acid is there, H plus is equal to dissociation constant into given concentration of acid. So here we can write H plus is equal to, just check what is the value of Ka, 1.8 into 10 to the power minus 4, 10 to the power minus 4, concentration of acid is 0.02. Directly student, you will get value in calculator, that is equal to 1.897 into 10 to the power minus 3. So this is H plus concentration. Now for calculation of pH, negative log to the base 10 concentration of H plus. So here student, put concentration of H plus, that is 1.897 into 10 to the power minus 3, and you will get value. Directly from calculator you will get pH, that is equal to 2.7. I hope you understood students. Now third problem student, find the pH of 0.02 molar solution of sodium hydroxide. As we know that this is the third problem. Third problem is related to strong base. So strong base, again students, direct formula. So when you need pH is equal to negative logarithm 10 H plus concentration. This is the formula for calculation of pH. But student, we know that here H plus concentration is not given. Whenever strong base is there that time concentration of base is given, and that concentration of base is equal to, if I write concentration of sodium hydroxide, it will be equal to concentration of hydroxyl ion. And student, from the given concentration is of concentration of hydroxyl ion, not of H plus. So for this purpose we have to use another formula, and that formula is POH is equal to negative logarithm to the base 10 OH minus ion. So directly now you have concentration of hydroxyl ion as, what is the concentration? See, 0.02 molar solution. So is given, that means it is also equal to 0.02. So negative log to the base 10 and 0.02. So from this equation you will get POH. So it is equal to, just fast students, 61.69. And now again this is first formula, and in case of strong bases you need to use second formula, that is pH plus POH is equal to 14, and pH is equal to 14 minus POH. Now we have 14 minus POH, you can take it as a 1.7 also, it is 1.69, or approximately you can take it as a 1.7. So your value will be 14 minus 12.3. So for calculation of pH of strong base, we need to use, when solubility product is not given, that time we need to use these two formulas. One is for POH and another is pH plus POH is equal to 14. In first step we need to calculate POH and in second step we need to calculate pH. Coming to fourth problem, students. Calculate the pH of solution of potassium hydroxide of concentration 0.05 mole per dm cube, and here given is ionic product of water, that is Kw at 298 Kelvin means 25 degrees Celsius. It is 1 into 10 to the power minus 14. So students, here we have to use method 2 because ionic product is given there. So write down expression. The first thing, write down expression for Kw is equal to concentration of H plus concentration into concentration of OH minus ion, and this is at 298 Kelvin. So ionic product is equal to 1 into 10 to the power minus 14 mole to the power 2 dm negative power 6. Now students, see, and here base is, this is your first step. Now for finding pH we need to calculate concentration of H plus. So, and concentration of OH minus is given but in the form of concentration of KOH. As KOH is strong base, so it dissociate into completely into K plus plus OH minus ions. So this is a KOH is strong base. So whatever concentration of KOH is provided, it is equal to concentration of hydroxyl ion. So concentration of KOH is 0.05. That means concentration of hydroxyl ion is also 0.05 mole per dm cube. Or here you can directly write down is equal to 0.05 mole per cubic decimeter. Now just student, rearrange this equation. Kw is equal to concentration of H plus OH minus ion, as we are calculating H plus. So concentration of H plus is equal to ionic product into concentration of hydroxyl ion is equal to, value is given 10 to the power minus 14 and hydroxyl ion value just we came to know 0.05. Calculate in calculator, students. So it is very easy calculation. So 2 into 10 to the power minus 30. So this is a concentration, so unit is mole per cubic decimeter. Now here you got your concentration of H plus, students. H plus is equal to 2 into 10 to the power minus 30 mole per cubic decimeter. Now calculate pH by using formula. pH is equal to negative log to the base 10 concentration of H plus ion is equal to negative log, put concentration of H plus value minus 30. Directly, students, from calculator you will get answer, that is 12.70. So 12.7 is pH of 0.05 mole per dm cube solution of potassium hydroxide. Pause it and if take screenshot. Now next problem is fifth problem. Calculate the pH of 0.02 molar solution of calcium hydroxide which dissociate to provide 2 moles of hydroxyl ions per calcium hydroxide per molecule of calcium hydroxide. This is some different kind of problem, student. So how we will solve it? Just first you need to identify this is calcium hydroxide and dissociation of calcium hydroxide, calcium 2 plus, it is plus 2 hydroxyl ions are there, 2 hydroxyl ions means 1 mole of calcium hydroxide generate 2 moles of hydroxyl ions. Hydroxyl ions. So students, as we know that there is a complete dissociation. So when there is a dissociation is complete, that time we use very simple formula. Here see 1 mole is giving 2 moles, but concentration of calcium hydroxide is provided. This is equal to, if we go to problem, concentration it is 0.02 molar means 0.02 mole per dm cube, but generating 2 moles of it is equal to 2 moles of hydroxyl ion. So student, whatever concentration of calcium hydroxide is given, we need to multiply with 2 because 2 moles of hydroxyl ions are generating. So 2 into 0.02, it is equal to 0.04 moles per cubic decimeter. Now student, use again this formula. Here you get a concentration of hydroxyl ion. So POH is equal to negative log, because ionic product of water is not given, so use this formula. OH minus is equal to negative log 10. You got value of hydroxyl ion, that is 0.04. So just directly calculate in your calculators. So value is nearly 1.39, so you can take direct approximately 1.4. Value of POH is equal to 1.4. As we know, pH plus POH is equal to 14, and pH is equal to 14 minus POH. So 14 minus 1.4. Just use your calculator students and put answer in comment. It is equal to 12.6. So pH of calcium hydroxide solution is equal to 12.6. Students, you need to identify. If ionic product is given, use simple expression Kw is equal to concentration of H plus into hydroxyl ion. But if ionic product of water is not given, then use this method. The sixth problem, that is given 0.05 molar solution of hydrofluoric acid with a dissociation constant, student. So here we need to calculate pH. As here, how to identify weak acid and strong acid? If student dissociation constant is given here, that means in problem you need to use dissociation constant. This is a very simple way. Which number problem it is? 6 number problem. So in 6 number problem, use directly formula for weak acids. Weak acid formula, as you know, H plus directly, because we already derived this formula many times. So directly we will use formula dissociation constant into concentration of acid. So Ka, we will put value of Ka here, dissociation constant, that is 6.8 into 10 to the power minus 4 into 0.05. So directly you can calculate, students. Just let me check one more time. 6.8 into 10 to the power minus 0.05. So 5.83 into 10 to the power minus 3. This is again you are calculating concentration. So mole per cubic decimeter. Now it is very easy. After getting H plus, you can calculate pH is equal to negative log to the base 10 H plus concentration. Put this H plus concentration value in this formula, is equal to negative log 10 5.83 into 10 to the power minus 3 in calculator, student, just find out what is the log of 5.83 to the power minus 3. it is equal to 2.23. So pH of solution is 2.23. This is weak acid, so we use this formula H plus is equal to dissociation, under root of dissociation into concentration of acid. 7 number problem, that is calculate the pH of 0.01 molar acetic acid, means 0.1 mole per dm cube acetic acid solution is ethanoic acid. Ethanoic acid formula is also given. The dissociation constant of acetic acid is 1.8 into 10 to the power -5. Dissociation constant is provided, and this is organic acid. That means this problem is related to weak acid. So students, what we will do, we will use the formula, that is H concentration of H plus. We are not going to derive this formula, just learn this formula. H plus is equal to under root of dissociation constant into concentration of given acid. So here ethanoic acid is given. So value of Ka given is 1.8 into 10 to the power -5. Concentration of ethanoic acid is 0.1. You can directly calculate like 1 point, that means it is 18, or instead of taking 18 student, take 1.8 into 10 to the power -6, as 0.1 is 10 to the power -1. So 1.8 into 10 to the power -6. Now it is very easy to get under root, that is 1.34 into 10 to the power -3. Concentration unit is mole per cubic decimeter. Now in this way you got concentration of H plus ion. Now put your pH formula. pH is equal to negative log. If you want to put base 10, put, otherwise no need. 1.34 into 10 to the power -3. Direct answer students, 2.87. So pH of 0.1 mole per dm cube of acetic acid solution is equal to 2.87. If you need, take screenshot. Now there are PYQ students, previous year questions. So just we will discuss one question here. The Ka value for some acids are listed below. Use them to answer the following questions. You have given some acids and their dissociation constant values, that is acetic acid, methanoic acid, hydrocyanic acid, hydrofluoric acid, and their dissociation constant values. Which of above acids has the highest value of pK? Now Ka value is given student, you need to calculate its pK value, or when you know relationship, if Ka is high, that means it has low pKa. Keep this thing in mind. There is a relationship Ka, pKa. As we know that pKa is equal to negative log to the base 10 Ka. So whatever value of Ka is there. So students, keep always one thing. 1 minute. There is a relation Ka, pKa and strength of acid. If you have problem, see my video for strength of acid, where you will find this. So Ka, if value Ka is directly related to strength of acid. If Ka value is high, acid is strong acid. And we are taking logarithm for calculation of pK, so its value is low. When Ka value is less or low, then acid is weak acid, and that time student you get higher value of pK. So Ka is directly proportional to strength of acid, but at the same time Ka and pK are inversely proportional to each other. So this table is very important. Note down this table. because if you do not want to calculate this pK student, from this also you can easily get it. Now in this table, if you find HCN value, it is 4.9 into 10 to the power minus 10. So student, here if you check this value, you will find that if you compare, if you want, you can take a logarithms also. Here you can take a pK is equal to, you put this formula and you can take log also. See, if you want to, that also by method I will tell you. pKa, take log of these values is equal to negative log Ka. If you take log of all these values, students, just if I will take log of 1.7 10 to the power minus 5, it is 4.77. It is 1 point, its log is 3.79. Its log is 19.30, and 5.6 into 10 to the power minus 4, 3.25. This is also easy. If you find the highest value of pK, so you will find that HCN has the highest value of pKa. But if you compare Ka value, student, we will find this Ka value is lowest value. So without taking log also, you can, if you will find this lowest value, you can easily find that it should have highest value of pKa. So this is the lowest and this is the highest. So this is weakest acid here. Now, so above a highest pKa value is HCN. If you take log, it is easy to, you will get answer. But if you don't want to take log, and you can compare this minus negative powers. So 10 to the power minus 10 is lowest here. So as per number 11, if it is lowest, students, means its pK value should be highest. So HCN is answer here. Now for methanoic acid, means we have to choose methanoic acid here. We have to focus on methanoic acid now. This for methanoic acid, write expression for Ka for methanoic acid. Now methanoic acid, it is given, it is many times we used in our problems. So when you have to write down dissociation expression, students, you should know how to write dissociation of acid. It is SCOOH. So aqueous form, it will dissociate into methanoate ion, aqueous plus H plus ion. It is acid, so it will lose H plus. This is also in aqueous form. Now expression for Ka is equal to, as we know that this is equilibrium expression. So equilibrium expression means equilibrium constant. So product divided by reactant. So two product means we will take product of products, methanoate ion, concentration of, and concentration of H plus ion, and divided by reactant, that is concentration of given acid. So this is your, student, expression for Ka. This is also called as equilibrium expression for methanoic acid. Now third is calculate the pH of 0.08 mole per dm cube solution of methanoic acid. Now in our worksheet also we used methanoic acid and similar type of problem, student. This is organic acid, again it's a weak acid. Now it is very easy to calculate. Use formula H plus is equal to under root of Ka into concentration of acid given is equal to value Ka value from, you need to find it from box, that is given table, into 10 to the power minus 4 into concentration of acid is given. This is concentration of acid, it is 0.08. Calculate, student. It is equal to 3.5 into 10 to the power minus 3. This is concentration. Write unit mole per cubic decimeter. After getting H plus, it is very easy to get pH. pH is equal to negative log to the base 10 concentration of H plus. So if you are taking H plus concentration means negative log to the base 10 concentration of H plus already you calculated, that is 3.5 into 10 to the power minus 3. It is equals to, students, just use your calculators, pH is equal to 2.44. So this is the worksheet and some PYQs we have already discussed, but this table is very important to compare values of Ka and pKa. And again I am telling you, if you have strong acid, your formula should be direct formula, pH is equal to negative log to the base 10 concentration of H plus, because concentration of H plus is equal to acid given due to complete dissociation. Now if you have strong base, use two formulas. The first one is POH is equal to negative log to the base 10 concentration of hydroxyl ions. From this you will get OH minus ion, and pH plus POH is equal to 14. So 14 minus POH you will get pH. Another formula is KW is equal to, that means ionic product of water, H plus OH minus ion. From here you will calculate H plus ionic product of water over hydroxyl ion concentration. And student, after getting H plus, again use formula pH is equal to negative log to the base 10 concentration of H plus. Third is weak acids. For weak acid, how you will get concentration of H plus? Because this is an incomplete dissociation, so extent of ionization is given by dissociation constant. So Ka into concentration of acid provided in problem. So after getting H plus, put it into formula, pH is equal to negative log to the base 10 concentration of H plus ion. So student, these three formulas you need to keep it in mind, because here in case of weak acid, concentration of acid given or initial concentration of acid is not equal to concentration of H plus. This is very essential, students, and important thing. Strong acid, your formula should be the strong base. Your formula, it depends upon what is given. And weak acid, this should be your formula. It should include dissociation constant.